Welcome back. How was this exercise? Let's go step by step and see how your answers match up. First one, sort 10 schools around your house by distance. So the input is only 10. It's fairly small. We need something simple. In this case, I'll probably use insertion sort. It's really fast on small sorts. It's easy to code, and it has space complexity of O of 1. It also could be that these 10 schools are already pre-sorted or are nearly sorted on our list. So insertion is just the simplest for this type of small data. I like insertion sort for this type of things. What about this one? This one's a tough one. eBay sorts listings on their website by the current bid amount. So what would you use for this? Well, for this, I would actually use something like radix or counting sort. Because, well, a bid is usually a number between, let's say, $1 to, let's say, 50,000. Probably even less when it comes to payment on eBay. Let's say $1 to $100. These are numbers that need to be sorted, right? And because it's a fixed length of integers, integers are most likely not going to be 100 million because, well, hopefully nobody's bidding that much on eBay. So I would use radix or counting sort to beat that O of n log n time, knowing that the bids are always going to be number within a certain range. What about, not sort, sports scores on ESPN? Well, sports scores can vary. There's decimal places sometimes. There's different formats such as tennis and soccer and different things. And there's definitely lots of sports and lots of scores to handle. In this case, I'm going to use quicksort. It's going to be the most efficient. And although we might have the worst case, I doubt that the scores are going to be sorted because there's just so many different kinds. But I'm also worried about in-memory sorting. So if I used merge sort, it might be a little too much for this because of our increased space complexity versus quicksort, which, if we remember, has better space complexity. And by the way, you might have your own answer for this. Maybe you thought that the sports scores on ESPN the inputs would be a little bit different. You can have your different types of answers. The idea here in an interview situation is to explain yourself. And if you know the principles, then the interviewer is going to say, oh, he or she knows what they're talking about. Number 4, massive database. So we can't fill all this data into memory to sort it. So we probably need to sort it externally, and let's say we need to sort through past years' user data. So it's a ton of data, and we need to sort it somehow, let's say, by some sort of a date. Well, based on the information that I got here, it sounds like I need to do something called merge sort, my favorite type of sorting. And the reason I would pick this is because, well, it sounds that we're not going to be sorting really in memory because the data is so big. But because the data is so big, I'm really worried about the performance. I don't want the worst case of quicksort of O n squared. I want to make sure that no matter what, I'm going to get O of n log n. What about the 5th one? There's an almost sorted Udemy review data that needs to update and add 2 new reviews. So we have a massive list of Udemy reviews. Let's say that you rated the course and this course that you're taking has 500 reviews and you and your friend just added 2 new reviews to this course. In this case, I'm going to use insertion sort. And why is that? Well, although this data might be huge and maybe I have a lot of reviews, I'm assuming that most of the previous data is already sorted. And all I'm doing is adding 2 new reviews to this data. Insertion sort for pre-ordered lists is going to work better than any other type of sorting. Number 6, temperature records for the past 50 years in Canada. Oh boy, what should we do with this one? And this is a little tricky. I would say that first, I would use something like radix or counting sort. If the temperatures have no decimal places, if we're saying, it's minus 30 to, let's say, 40 degrees. That's a integer number between a small range. That might work well. But if I want to sort through data that also has maybe temperatures that are really accurate and have decimal places, which you can't do with radix or counting sort, then I'm probably going to use quick sort again, just so we can do some in-memory sorting and hopefully save on that space complexity. All right, last two. Large username database needs to be sorted. Data is very, very random. All right, so we have a username database that needs to be sorted. I'm not really sure. I don't have enough information to make a decision here. Maybe I would use merge sort if we have enough memory and memory isn't too expensive on the machine. Or maybe I'll use quick sort if I'm not too worried about worst case and that the username database isn't that large. Maybe I'll just use quick sort just to save on that memory space. And then finally, number 8, you want to teach sorting for the first time? This was a little fun question. I said bubble sort, just so I can add bubble sort to this list and selection sort. All right, hopefully you had fun with these questions. Sorting algorithms, this is probably the funnest I can get it. Actually, no, I lied. The Hungarian dancing to sorting is the funnest you can have with sorting. But I hope you have a good idea of how to answer these questions when they come to the interview. I'll see you in the next video. Bye-bye.